Hi everyone, this is Jake Fry again, and this lecture will be a very brief introduction to acceleration. And so we're still in the process of describing motion and how we set up a problem in physics. And so in our previous lecture, we explained how to describe an object's average velocity, which was the average rate of change of our position vector. And we also motivated the idea of attaching inertial reference frames to certain objects as they move around to make it very useful in solving problems in kinematics. And now the next very common idea that we use in our daily lives is acceleration. And while normally we think of acceleration as something that always causes an object to speed up, in physics, the definition of acceleration will include both speeding up or slowing down, and even changing direction. And so recall that the average velocity is given by the displacement divided by the elapsed time, as shown here. And in a similar fashion, the average acceleration is the change in the velocity vector over an elapsed time. And remember, last time I said that the direction of the velocity vector was the same as the change in the position vector, so they point in the same direction. And the acceleration here is also in the same direction as the change in velocity, because the change in velocity is the only vector on the right-hand side of that equation. So if the velocity change is getting smaller, then we would know that our acceleration is negative, so it's slowing down. And if the velocity vector, turns, then we know that it's changing the direction. Or the most common acceleration that we know is something speeding up. But all three of those changes in the vector of velocity are allowed. And we'll see that the concept of acceleration will be very useful in describing the motion of many everyday problems, such as an accelerating vehicle or a dropped object, so that involves gravity. So gravity will become very important later on, but it's the most important acceleration that's in our daily lives. And also objects slowing down. And so you might think, okay, if we know, the position, the time, the velocity, and the acceleration, is there anything more that we would need to know in order to describe motion? And in fact, you can actually continue this idea of the rates of changes of these vectors to create an extremely long, actually infinite list to describe the motion. But most of the problems that you'll encounter in Introduction to Classical Mechanics won't go much further than the acceleration vector. And typically, you would employ calculus in order to figure out the next ones. But they, the first six all have names, which get kind of silly. But the rate of change of acceleration, and I'll describe what all these symbols mean in a later lecture. But the rate of change of acceleration would give you a jerk. And so that would occur like if you're constantly accelerating in your car and you all of a sudden see a deer pass in front of you. Well, you might hit the brakes really quickly, and that will change how much acceleration is happening. And so that's a jerk. And you can kind of think of it because, it jerks you when you hit the brakes suddenly. And then further on, we get into apparently Rice Krispies. So the rate of change of a jerk is a snap, and the rate of change of a snap is a crackle, and the rate of change of a crackle is a pop. And I think that anything beyond that doesn't have a name, but you can prove me wrong if you want to. But all that matters is that the rates of changes can have an infinite series of changing. So you can describe extremely complicated motions, all based on the rate of change of your position with respect to time, and continually getting new types of slopes. But anyway, for our next lecture, we'll get into more mathematics in order to describe the situation in a calculus-based way, which, in fact, is the better way to try to solve these kinematics problems.